Hi there. So we're going to talk about OSPF, Open Shortest Path First. So this is like one of the most popular routing protocols, if not the most popular. It's very widely used in today's lands. So chances are you're very likely to be running into OSPF in the real world. Um, so for the CCNA, you have to be able to configure a single area OSPF network as well as multi-area, I believe. So let's first start talking about single area, and then maybe there'll probably be like a future um, discussion about multi-area OSPF as well. So for So with OSPF, so what is OSPF? So it's a routing protocol, and it's a way to share routes between other OSPF like participating routers. So it's an easy way to propagate routes throughout your network without having to sit down and manually configuring each one. Um, so with OSPF, the base like network is area 0. So that's like the like your main like backbone like area. So if you're talking about like a single area like OSPF like configuration, you're talking about area 0. So you'll have area 0 and multi area as well, but um, it's not going to be the only area. So that information, the routes are going to be shared between multiple areas. So so in this particular case, we're only going to worry about one area. So uh, so what's the idea of like this area? What's the point? Well, the point is like we need to be able to in order to share information between routers participating in OSPF, they have to be on the same area. Um, so when you advertise a route, you have to associate it with a particular area. In this case, we're going to be talking about area 0. So, so on a router, we have a bunch of like routes, and those routes are associated with particular network interfaces. So in order to share those like routes with other routers participating in OSPF, we have to advertise them. And this is the same idea with any routing protocol. We have to um, we have to advertise them out. In order to advertise them out, we have to do like a particular configuration, and you know, depending on like what routing protocol you use, like the configuration could be like slightly different. So when you start with OSPF, so OSPF version 2 refers to IP version 4, which is what we've been mostly discussing so far. So IP4, as you know, are 32-bit IP addresses. So that's what version 2 of OSPF refers to. Version 3 of OSPF is the extension um, to OSPF that allows it to deal with IP version 6, which we'll be talking about another time. So in order to enable OSPF on your router, you have to do the command router space OSPF space and then whatever the process ID number is. The process ID number is arbitrary. It does not have any pertinence to other routers. It only has pertinence to your local router. So this allows you to potentially run like multiple instances of OSPF. So when you're adding configurations to OSPF and you wanted to add it to the same process ID number, you should specify that when you enable OSPF. So, or when you have to go back to configure it. So that way everything's under the same process ID. And you can easily see your process ID number by looking in your show running config as well, if you want to go back to it later. So if you have so you have a bunch of networks, so a good idea is when you're trying to advertise your networks, you want to list them all out. And you could just do a show IP route. The show IP route command is a way to display your routing table. And so when you display your routing table, you'll be able to see all your routes. So you do the show IP route command, and that'll let you see all of your directly connected routes. And you can just easily go through and add each one that you want to advertise. And so in this particular case, I'm advertising the 10.0.0.0 network, which is a Class C network, on area 0. So I'm using area 0 here. That's how I specify what area I'm going to advertise this network on. So now this is kind of weird. So what is this here? So this is known as the wildcard mask. So it's actually pretty easy to find the wildcard mask. All we have to do is first get the subnet mask, which is, since this is a Class A, is 255.0.0.0. So what you do is you just subtract, you subtract 255 from each of the octets. So for the first octet, I have 255. Well, I subtract 255 from that, I get 0. So the next one I have 0. So 255 minus 0 is 0. And the same thing, 255 minus 0 is 0. So I'm on the third octet. Now I'm on a fourth octet. 255 minus 0 is 255. So so for the last three octets, I'm subtracting 0 from 255 that gets 255, not 0. So that's how you get the wildcard mask. So you just kind of look at each octet and you subtract from it the subnet mask, 255. So 255 minus whatever the subnet mask is. So in that particular octet, and you just go octet by octet by octet. So that's how we advertise a network. So I'll do this for each network that I want to advertise. Now, with OSPF, each router in your area is going to be distinguished by its router ID. By default, it's going to take the IP address of your router. It's going to take the highest IP address. This is kind of a little unpredictable in some cases, because your IP addresses are not necessarily they're not really used for OSPF per se. They're used for how you control the flow of your or how you organize your network. So you might actually get you might not want to use a particular router ID. So as opposed to using a IP address of particular network interface, you can actually use a loopback adapter IP address. So in that particular case, if we want to override the router ID, we can use the loopback address to do that, or we could just specify manually the router ID. So this really comes into play when you're trying to do an election on your network, to decide which router is a designated router. The router that has the highest router ID becomes the designated router. So if you prefer one particular router to do it over another because it maybe has a faster link, maybe it's a faster router. Um, you can control that using a router ID. And so you have passive interfaces. Passive interfaces, like, we can actually enable that by going into the router configuration. So again, I'm going back to my router OSPF 10, and I just say passive dash interface and space whatever my interface is, and that will enable passive interfaces. So it'll turn off like router advertisements on that particular interface. So when you are talking about multi-area OSPF is useful to kind of like break up your network into like so you have more of like a hierarchy, and it doesn't get too saturated with like link state, like updates and whatnot. You can kind of control your traffic more by dividing up your areas that way, and dividing your network that way. And so when you have like multiple areas or where they meet, the area border routers, they're going to be doing more of like the route summarization. So that the areas don't really need to know all like the gory details. So that's where the summarization comes into play. They kind of simplify like the network, like traffic, like lessen it, so that way there's not as much like saturation there with link state advertisements. So we have different types of like LSA types, link state announcements, or advertisements rather. We have the router LSA. So let's take a step back. So LSAs are the packets that are sent by OSPF to make sure that routers are like on the same page. The routers that participate in a particular area in OSPF. So a router LSA is going to give like give out its links in that particular area, and also includes like the router ID. And the network LSA is used to give out the designated router's IP and the backup DR. The subnet mask is also given. This is only for a particular area, so the backup DR will kick in if the DR, if there's like a problem with that. And the designated router comes into play. It has an important role for link state announcements and advertisements, in the sense that it's the one that like disseminates it out on a particular like multi-access like network. So the DR like is in charge of like disseminating those LSAs, so that way not everybody has to do it. It's just kind of given over to the DR, the designated router, as well as the backup DR. So they are in charge of it, but the DR is the one that does the work, until like if the backup DR has to take over. And finally, the summary LSA is a subnet mask RID, the router ID of the area border router. It summarizes routes from another area, so that comes into play for multi-area OSPF. So given that, let's just do like a little like example of OSPF here. So I'm going to open a packet tracer, and I'm going to create a couple routers. I'll just add a few here. So I'm adding three 1841s. So I'm going to call this one router 1. This one's going to be router 2. So I'm just configuring my routers, and now I'm going to connect them together. So I should have fast Ethernet connected to all these. So I'm going to do like a little loop here. Alright. So they're all connected to fast Ethernet. And I'm just going to use so I'm just going to create like a few networks here. So here's the networks I'm going to do. I'm going to do, so these are going to be point-to-point networks. I'm going to do 192.68.0.0. And this is going to be /30 networks, so they're point-to-point. The next one's going to be 0.4, 30. So those are my networks. They'll just keep it up here. So this one's going to be the connection from router 1 to router 2. This will be from router 2 to router 3. This will be from router 1 to router 3. So those are my networks. So they're point-to-point networks. They're all /30. So that means they have two addresses and a broadcast address and network address. So let's go through and let's just configure the interfaces. So I'm doing router 1. So what do I got here? So router 1 has, so the connection will start with router 1 to router 2. So this is what? 0 to 0, F00 to F00. Okay, so I'm going to make this .1. Then do a no shut. So since I'm doing fast Ethernet, I don't have to do clocking. This is kind of, a lot of Cisco exercises you're probably used to seeing serial point-to-point connections, but we're going to use fast Ethernet in this particular case. Okay, so while I'm here on router 1, I might as well just configure the interface for the connection between router 1 and router 3. So what is this here? This is going to be F01. So F01 is going to be IP address 192.168. Just going back to my my IP address table here. So .8 is going to be the network, so it's going to be .1, or I'm sorry, .9. And so it looks like I made a mistake here, so let me go ahead and correct that. I used the wrong subnet mask for my IP address. So let me correct that. So it's complaining that I had overlap in IP address in there, so hopefully that should be fixed now. Okay, now it's looking good. Alright, so router 1 is looking good. So let me go on to router 2. So router 2 0 F0 F0 F00 is going to be connected to router 1. Do a no shut there. Now go on to the next one. I know it's going to be F01. Why? I'll just look just to double check that's correct in my workspace here. So it's F01 connects to router 3. So I put IP address 192.168.0. So R2 goes to R3. It's going to be .6. Oh, looks like I made a mistake here, so let me go back. F00. So actually be 2. So 2, 3. Yep. So that is correct actually. It's like I made a mistake somewhere. Let's see what happened. It's not happy about something, so the connection from, alright, so I did R1 to R2, now I need to do R2 to R3. Alright, let me see what I did here. Show IP int, whoops, brief. Okay, so it looks like I made a mistake here. So F00 should be (680.2) and 01, which is already correct. So that's going to be .6. Alright, so that's looking good. So I just made a little mistake there. Sorry about that. So it should be correct now. So this is a connection that goes to R1, and this is a connection that goes to R3. So finally, let me do R3. So F00 should go to router 1. So let me put that in. So router 1 will be IP address 192.168.0. So we have 9. 9 goes for router 1, and 10 is for router 3. Do a no shut. And F01 will be IP address 192.168.0. So this is the one that goes to router 2. So the first address for that network is 5, which is for router 2. 6 is going to be for, or wait, I could be wrong about that. I think 6 is actually for router 2. So, okay, so we'll actually use 5. Now, whenever you configure interfaces, you should do a ping. So I should be able to ping my directly connected interfaces. So I'm directly connected to router 1, so I can go ahead and do, let's see, router 1 is on 9. So is it working? Okay, that one works. So I'm able to ping router 1. Let me try pinging router 2. Alright, this one's not as happy. Okay, so let me try to figure out what's going on there. So show IP in brief. So I have .05. Oh, looks like there's a problem there. So maybe I didn't do a no shut on there. Let me see. Still not coming up. Well, it looks like I forgot to bring it up here, so F01. No shut. Okay. Alright, they should all be up now. Let me try doing a ping again. Alright. So let me try pinging router 1. Try pinging router 2 from router 1. Whoops. Wrong IP. Okay, it's router 2, so let me try router 3. Okay, it's looking good. So now I have complete connectivity here. Well, at least my directly connected router. So I do a show IP route. I can see like the directly connected routes here. So let me enable OSPF. So I'm going to do config terminal, router OSPF 10. So I'm just going to use process ID 10. It's arbitrary. Now I have my networks listed here. So I'm just going to go ahead and add them in here. So 192.168.0.0. Then I'm just going to calculate the wildcard mask. So the first 3 octets are 255s. So those are automatically going to be zeros. So that's because I just subtract 255 with 255, I get 0. So I subtract 255 with 252, I get 3. So then I'm going to do this with area 0. Now I'm going to do the next network. The next network is 8. So now I should be advertising those out. So let me go to router 2. Again, I'm going to do show IP route to see what networks I need to advertise. Config T router OSPF 10. I'm going to do 168.0.0. These are all going to have the same wildcard mask. So I'm going to advertise this one out first. Now I'm going to do the next one, which is 4. Okay, that one is done. So as you can see, status message came up here. There's a adjacency that it formed. So OSPF is already starting to communicate. There's some communication that's happening already. An adjacency is forming. Finally, let me do router 3. So again, I'm going to do show IP route. So I have to advertise 2 routes out here. Router OSPF 10 network, and I'm going to do the first network 168.0.4 0.0.0.3 area 0, and I'm going to do the next network, which is .8, and So again, another adjacency form. So if I do a show IP OSPF, so it's just some basic information about OSPF here. And I didn't set the router ID, so it's just going to take the highest IP address of my interface, which happens to be 192.168.0.10. And I have a number of commands I can do with show IP OSPF. I can see the database. So these are the different links that are, in my database. And I can also see the neighbor. So these are the neighbors that I recognize, so router 1 and router 2. So router 1 is on .9 and router 6 is .6. So it has a full adjacency with it. So that means it's passing link state advertisements with that neighbor. So when there's a full adjacency, it's passing link state advertisements with that. So okay, so now that I have that in place, I should be able to ping any network interface that I want. So let me try to ping a interface on, let's see here, so I'm on router 3. Let me try pinging the interface that goes from router 1 to router 2. So that's 0 dot, let's see, 2. It worked. So if I do .1, again, it worked. So I'm not directly connected to those interfaces. That's the connection between, that's on the connection between router 1 and router 2. Right here. So I'm trying to ping from here to this interface, and it's succeeded. Why? Because now I have a converged topology. My OSPF routing protocol converged, so I have a complete picture of the topology. So if I look at my routing table, I should see some entries from OSPF here, and here they are. So I gained, so with any particular router, there's one route that I'm not directly connected to. So I get two routes that, that are directly connected, and I get another route that's not directly connected. That's where the OSPF advertisement, the link state advertisement comes into play. So here it is right here. So I have two particular routes here. So one goes through F0/1, and this one goes through F0/0. So I have two particular routes to this particular network right here, 192.168.0.0. So I'm going to see this on each particular router. Show IP route. So I'm doing show IP route on router 2. Again, I'm getting one, so I have OSPF entry right here. How do I know? Because it has the O here for OSPF, and C is for directly connected. So it's getting two routes for OSPF here, and it's gonna load balance between them, because they have the same metric. The metric is 2, and this is the administrative distance. The administrative distance for OSPF is 110, and it can get to this network using F0/0 or F0/1. And I'll see the same thing on router 1. I'll see two possible exit interfaces for one network, because I have, so for instance with router 1, in order to get to this network here, I can go through this network interface, or I can go through this network interface. So it's going to load balance between them. in order for it to prefer like one particular route, I'd have to change the cost. So I can do that by going to, let's say, F01, and I can just do, let's see what I have here. I have IP, and then I can do OSPF, and cost, and I can set the cost to be, I don't know, 100. So now it should update my routing table. So F0 F01 should have a higher cost than F00. So I just took out one of those routes by changing the cost. By changing the cost, I was able to take out one of those routes, or one of those interfaces, because there was two interfaces that showed up for this. Because router 2 has two ways to get to this network right here. But I took one of them out. I took F01 out, this one right here. I took this one out by giving it a higher cost. The cost is 100 versus, I think this one was 6. Or 2 rather. So it was 2. So this one is the one that won, when it was looking at the metric. So this is the metric here. This one had a better metric than the 100, which I manually set. So this is just an example of like OSPF in action. Hopefully this was helpful. Thank you.